name is Michael Parker and welcome to the first in a series of videos that will explore how to use certain aspects of GIS software. These videos will be tailored towards complete beginners wishing to gain a wider understanding of ways to visualize and manipulate LiDAR data beyond the freely available LiDAR viewers such as ArcEye UK or CalTopo. Also, to learn other functions within GIS that are useful for archaeologists and archaeological prospecting. By the end of this first video, you should be able to download the GIS software, visualize aerial photography, and on this, be able to overlay a LiDAR data tile in hillshade view. Ways of manipulating this LiDAR data and other functions will be covered in subsequent videos, but I wanted to get you up and running and at least able to start viewing your areas of interest before I explained a little more of some of the functions you were using to do this. I suggest you watch this video all the way through before attempting the process. It's one of those where you need to pause and rewind a bit to get all of the detail. However, if you can manage to complete the steps in this first episode, I suspect any future information I add will be relatively easy in comparison. GIS stands for Geographic Information System. The software is used to capture, store, manage, analyse, map and visualise all types of data by using its location. It is used in many industries, including archaeology. There are a few types of GIS software on the market in general use, such as ArcGIS or Maptitude. However, most have a cost attached to them, which is why many seek a free alternative. QGIS is a free, open source, frequently updated GIS software that has a large community supporting it. It is for these reasons many have chosen this software and why I'll be using it in these videos. It is advisable to use this software on a laptop or desktop computer. It's not suitable for the small screen size of a phone. So let's get started and download the software. Navigate to the QGIS website by simply searching qgis.org. The download button is at the top of the screen. Click here, then donate or skip this option. You are then presented with the download options for different operating systems and a complete installation guide. Follow the appropriate steps to install the software on your computer. OK, I'm assuming you've been able to set up the software on your computer, and you should now open it up. Firstly, we will have to start a new project. Simply click the blank piece of paper icon in the top left-hand corner of the screen, then Project, Save As, give your project a name, and set the project home to where you want it to be saved. A project is like a folder in which all the layers and data are kept. It's important to understand the GIS software works by visualizing layers. These can be map layers, aerial photography layers, LiDAR layers, or other data. These are stacked like a deck of cards, one on top of the other, and we get to decide in what order. We can also turn them off and on, and if we wish, we can change their transparency, and so visualize one through another to achieve the desired view. The main area of the screen is where your maps, aerial photography, data or LiDAR layers are visualized. On the lower left-hand side of the screen, the name of each layer will appear as we import them. At the top of the screen are all the other options and processes available to manipulate the layers or create new ones. In the bottom right-hand corner of the screen, you will see the Coordinate Reference System number, or CRS number, for the project. This will need to be set before we go any further. The Coordinate Reference System relates to the way that location data is recorded on each layer you will be importing, and can vary between layers according to the way the data was gathered. Luckily, QGIS uses an on-the-fly system to convert imported layers to the project CRS to make sure that they line up on the screen geographically. There are websites such as spatialreference.org to help you if you have a problem here. But I've found the easiest way to obtain the correct CRS number is to search on the internet using the following. For QGIS, what's the EPSG code for England? Or wherever you are searching. It may give you several different codes, but just go with the first answer it gives you. This can be changed later if it causes a problem, so don't worry. Now return to QGIS. Left click on the number. This will bring up the project properties window. And then to the EPSG number in the top bar. Don't forget to add the colon in the middle. This will bring up the matching CRS numbers in the bottom panel. So click on the preferred option. This should show you a small map of the area in question. Then click Apply and OK. Basically, setting the CRS number correctly means you shouldn't have to worry about lining layers up, so long as they have a recognised CRS number embedded in the data. Which means the layers we will be dealing with in this episode, aerial photography from Google and LiDAR data, should line up without a problem. I've set mine to England because that corresponds with the LiDAR data I'll be downloading later. We are now ready to import our first layer. The first layer we will be importing is a Google Earth imagery layer. To do this, we will have to install the plugin HCM GIS. Think of plugins like apps on your phone. They allow you to perform certain tasks or processes. The HCM GIS plugin has, amongst other things, all manner of base maps that may be used as a platform onto which other data may be overlain. To download it, click on the Plugins menu at the top of the screen. Then click on Manage and Install Plugins. On the left-hand side of the newly opened window, click All. Then at the top, search for HCM GIS. Click on the plugin and then click Install. You will see a new menu option at the top of the screen called HCM GIS. You can now close the plugins window. Now, click on the HCM GIS menu at the top of the screen. Then Base Maps, then Google Satellite. You have just imported your first layer and it has appeared in the left-hand layers panel. And, as with all layers, it can be turned on or off using the tick box. If the HCM GIS menu option does not work, close QGIS and then open it up again. This is sometimes required when plugins or processes are newly added. In fact, this advice works for most problems I've encountered in QGIS. Navigating around the layer may be achieved in two ways. By far the easiest is the mouse, where you simply left-click to grab the layer and move it accordingly. If you have a scroll wheel on your mouse, this performs the zoom in or out function. Moving around otherwise is done by clicking on the hand icon, then left-click grabbing the layer and moving it around. The zoom in or out functions are the magnifying glass with the plus or minus sign in them. Select the appropriate zoom function, then click on the screen. We are now ready to download our first LiDAR data tile. The quality of hillshade visualization you are going to get is dependent on the quality of the LiDAR data recorded. So if the distance between each LiDAR data point is smaller, the greater the detail in the eventual LiDAR hillshade view. 1 meter data is perfectly good for archaeological visualization and prospecting, but if you can get 50 centimeter or even 25 centimeter, all the better. With anything larger than 1 metre data, it starts to get pretty difficult to see anything of any subtlety. For this first example, I'm going to download LiDAR data for England. We need to download LiDAR data from the regional data source. In the case of England, this is the DEFRA website. So search for DEFRA LiDAR data. Click on the National LiDAR Programme. Then scroll down to Survey Data Download and click on this. Zoom into your area of interest and you will see that the landscape is divided into squares. These are the areas that the LiDAR data has been broken down into and are called LiDAR data tiles, and they each have their own reference number. Select Draw Polygon. Then, by clicking in the area, draw a rough shape. This is telling the site which tile you want. If you make the shape cross into other tiles, you'll be telling the site that you want more than one. But for now, let's just download this one tile. Once you have drawn your shape, click on Get Available Tile. We want the LiDAR DTM data, so select this. The 2022 data is the only option here, and we have the option of 1 metre or 2 metre data. I have selected the 1 metre. Then click Download All. This will download a zip file into your Downloads folder. Once the download is complete, click on the zip file and then click Extract. Select the place where you wish to extract the files. Personally, I make it the same place that I saved the QGIS project so that all the data is in one place. So we are now ready to drop the LiDAR data onto the aerial imagery, and we can return to QGIS. It's simple enough to add the LiDAR tile as a layer into QGIS. Firstly, open the folder containing the extracted files. You will notice that several files were extracted in the download. The file we want is the TIFF file, which is a raster file. I will go into the meaning of this in a later episode, but just for now, drag and drop the TIFF file into the Layers panel. You will see it appear as a new layer on the main screen area and in the Layers panel. This view is called a Digital Elevation Model, or DEM. Each pixel represents a different height and location. This model was generated from the raw point cloud data collected as part of the LiDAR survey and needs to be further processed to obtain the hillshade view we require. To change this to a hillshade, right-click on the layer name in the Layers panel and click Properties. This will open the Properties window for this layer. Change render type to hillshade. You can change the Z factor as well. Think of this option as the contrast. I usually use a number around 10 here. Then change resampling to cubic. This tells the pixels how to relate to one another and creates the smoothed image. Then click Apply and OK. You will notice that when you zoom in, all the rows line up with the underlying imagery, and the landscape looks to be where it should be. The LiDAR tile has positioned itself exactly where it should geographically. This is because we set up the CRS correctly, and the LiDAR tile knows where to locate itself when we introduce it as a layer. If you get the CRS number wrong, then this is where it becomes obvious and the layers don't match up. I think you'll agree, this presents a really good image when compared to the freely available LiDAR maps, and you can play around with the Z factor to get your favoured contrast. Now let's alter the lighting direction and height. Right-click on the layer name again to open the Layer Properties window. You will see the circular dial image at the top. Move the direction indicator around and then click Apply. You can see that the lighting direction on the LiDAR hillshade has altered. Now let's change the lighting altitude. Here you have to think of 90 degrees as sunset, so the light is raking across the landscape at a low angle. This can be really useful when prospecting for archaeology. Then 0 degrees is midday, with the light shining directly down from above. Now let's try another example from the USA. I'm going to set up a new project for this because it's in a completely different place on the planet, and the coordinate reference system will be different to the English example I've just shown you. So this new project I've saved as Test 2. My area of interest will be North Dakota, so I've found the CRS and input it as the project CRS in the bottom right hand corner. I've already added the Google satellite layer as we did in the previous example. So all that's left to do is find the LiDAR data and add it as a layer. In the USA, the data source is the United States Geological Survey website. So let's search for the US GIS LiDAR Explorer. Click on the website. Launch the LiDAR Explorer application. At the top left, click on DEM. Then click on Show where DEMs exist and the 1 meter data. Then zoom into your area of interest. And draw a box by holding Ctrl and using the left mouse button. This should bring up a selection of LiDAR data tiles, or what this website calls downloadable products, within the area of interest. Click on DEMs within AOI. Then click on the 1 meter data. This should bring up a list of tiles that may be downloaded. Click on these tiles and it will bring up the download screen. Scroll down to type download TIFF and click on the file to download. Once downloaded, click on the file and then save it in the Test 2 folder. We can now return to QGIS and import the LiDAR layer as before. Drop the TIFF file into the Layers panel. And again, we can change the render type, Z factor and resampling to give us the hillshade view. And don't forget to save the project once you've finished importing all the layers. I've given an English and American example on this video, but it's the same process for any country. Find the LiDAR data source, download the DEM and import it as a layer. Just be aware the terminology around LiDAR data is not consistent between websites. Some call it LiDAR data, others call it DEM. You will have to play around if you're looking in other countries and see what data is available.
Well, I hope you've managed to follow that all the way through. I know this first bit's difficult and it's a lot to take in when you're new to it. I'm really looking forward to seeing any images you may generate, so please post them in the LiDAR and Aerial Archaeology Facebook group. Thank you very much.